Thank you very much. And thanks very much for your interest in this topic. Value is very much of an honest kind of concept. You don't have value unless somebody wants to use something as well as somebody has something to provide. And so this time we're going to talk about what's honest about AI and really how we have moved into a situation with a huge boom in investments. Goldman Sachs, I just read yesterday, says that there is $1 trillion of money invested in artificial intelligence so far. So this is a huge boom right now. I'd like to ask my panelists first to kind of open with how you are involved in creating value with AI. Corey, why don't you go first?
Sure. I love the framing of this as the honest look at AI, because I don't know what that says about all the other panels you all have been attending today, but just keep that in mind. So in Smart News, our mission is delivering the world's quality information to the people who need it. And for anybody who has worked in news over the last 20 years, who has built products in the journalism or news space, or is a journalist currently, if so, thank you for your service. This is a very challenging time. We've watched concentration in most major markets. Japan is a bit of an outlier on trust. Japan, though, still seeing decreasing trust in institutions and decreasing trust in media, compared to the rest of the world where we've seen intense increases in polarization, in distrust of virtually all ways of gathering the news. And as someone who believes fundamentally journalism is the foundation of plural democracy, I care a lot about reversing those trends. And what is exciting about the moments we're in is we're, a decade really into the resurgence of various forms of AI, and every, couple of years at this point into broad adoption of what folks will talk about as either generative AI or large language models as the latest examples of ideas that really were reawakened about a decade ago. And what gets exciting about this is, on the one hand, and this is excitement in the negative sense, generative is very good at creating credible nonsense. And so we are seeing a lot of fake things being created, and that makes my job harder. What makes it better, and what gives me hope, and now getting all the way to the value, is how do we apply this to ensure that when I deliver an article to somebody, when I choose how I'd like them to spend their time and attention, is it something that is high quality to them? Is it something that they want to see? Is it something they would regret not reading? And what we see every day working on this is that AI is crucial to that, and we couldn't possibly deliver on our mission without it.
That's great. Shane, how about you?
Yeah, so I'm on the kind of like a development team of the Gemini. Specifically, I co-lead the multilingual kind of post-training. So if you see any kind of problem with Gemini for non-English, that kind of falls on my team. So you can like ping me with like angry emails or something afterwards. But essentially, like we definitely cannot deny like AI is creating a lot of values. Technology is accelerating, and then I think we're going to see like more things. The kind of how I see the kind of AI development is that we basically master the algorithm of, say, offline sort of supervised learning, and that's basically like looking at the kind of behavior that humans do in text space, in kind of video, audio kind of things, and then we can sort of like imitate with sufficient amount of compute and data. We can imitate 80% of them. But basically, that's the kind of algorithm, 0 to 80%. So a lot of the places where people actually kind of find value is really human-in-the-loop kind of use of the AI. So it definitely cannot be fully trusted, but I can really do like 80% of the kind of job approximately. And that can definitely kind of alleviate like a lot of this kind of boring tasks. That's really for programming, for research, for like writing articles, for doing, it can like do it. But there's kind of always this kind of like human element that kind of needed there. So in terms of like, so we are like, say, provider of the kind of base model. That's kind of one, the kind of world's top model, probably there. 3 or 4 that's very competitive on that edge. How we're kind of doing is we're kind of making that as good as possible at the cheapest price as possible. In fact, like one person just like tweeted like one thing is like, so there's like Moore's law that will compute, but somebody can tweet as like Gemini law because they saw how good the Gemini Flash was going. Like Gemini Flash is getting like cheaper and cheaper. And then it's like somebody tweeted like every 2 weeks, the Gemini Flash decreased by 50% as like a Gemini law. So that's what we're kind of doing to create values.
Okay, so both of you have mentioned that there's a side of AI that's not completely trustable. So if you're using AI, how do you handle that matter of knowing what you can trust, identifying something that is a hallucination or something like that? Corey, why don't you go first?
So hopefully it's not news to anyone in this room. Don't just trust AI. Like, let's be super clear about this. Especially if you're doing math with it, then really don't trust current AI systems. But this actually applies to journalism in general, right? Any news story that shows up, whether it was written by a human or written by AI, is something that we always have to be critical in our thinking about it. And what tools and techniques do you bring to bear on that? And it's really not any different with AI, though the volume is really different. And sometimes quantity has a quality all its own. And so we think about it by mixing humans and AI, thinking about this as a partnership whenever possible. We, as a company, employ journalists, and we would be really foolish not to take advantage of that skill. We also look at, do you just ever trust one model? Also thinking about the differences between where are you using AI within your tool chains. It's very different to say, hey, AI, answer this question, as opposed to, hey, AI, help me get to a reliable source of information, or, hey, help me think about how to ask the question. The latter two AIs are actually pretty good at today. The first one we have all experienced, again, sort of this credible nonsense problem. And of course, the ongoing challenge is as Gemini gets better, as OpenAI products get better, the credibility of the nonsense is getting much, much higher, but not necessarily the factuality of it. And we all already went through this. Remember when the internet arrived? We used to think of facts as things that showed up in like bound books. And then we had to sort of decide, do we trust Wikipedia? And so we've been through cycles of norms around factuality and the signals to look for. This is another one.
And so, Corey, you actually have a product that people are using to select and prioritize news items and news sources and so forth. So Shane, I want to push this a little different for you. Since you're working on the basic models, what about somebody from the very beginning? If you're first getting involved or your company is thinking about adopting AI, what's kind of best practice procedure?
Yeah, can I also kind of build on his kind of point, because I think it's really kind of interesting. So definitely kind of first thing is really like always going to have human, and then be like, so AI is going to get better. It's going to be harder and harder for humans to discriminate what's AI versus not, what's kind of versus or not. But human basically need to like adopt it. It's kind of same problem. Like even before the AI, there's like this kind of social bubble, like social media has kind of created like a lot of this kind of news bombarded to you that align to your perspective, generally good based on the algorithm. And then you get sort of trapped into that kind of mindset and cannot like differentiate. So as AI sort of kind of gets better, like you need to kind of get better with the AI as well. Another kind of thing you can use is kind of getting interesting is that you can also...
So how do you get better along with the AI?
We need to just continually educate ourselves. I think the continual education, etc. I think the education is like the education reskilling. Those are like some of the most important topic I think these days, like that we should kind of focus. Another way to kind of do is like basically use AI to kind of verify the AI. So say 2 years ago, we had like a paper that's think step by step. It's basically like rather than answering A, B, or C, or D, basically you can ask it to provide a reason and then provide it. So it's kind of like a mess of test time compute. Essentially like instead of like one token that you kind of request in language model, you're asking for like 100 of tokens and then the prediction. That's kind of first step. But right now, basically people using to like AI or like a bag of AIs to verify each kind of step of the reasoning. So it's like, say, let's verify step by step kind of paper. So one is like, you can also kind of rely on kind of AI. So, but essentially like it's going to get harder. It's going to get harder for people to sort of like verify the AI's output as well. So what I can also recommend is also rely on the AI as part of the human, but you be in the kind of control seat. And then I'll kind of go to your question on the
About from the very beginning, how do you get started?
You mean like anyone can starting today?
Yeah, or if you're a business person,
right,
and you've got a company that's, let's say it's a medium-sized company, got the money you can invest.
So essentially, like my recommendation is that, so in the AI, basically there's like this pre-training phase, there's post-training, and then there's UX, or the final application. So pre-training is basically kind of where you basically feed in the internet, huge amount of compute, huge amount of talent needed to really kind of make it work. Post-training is like really kind of fine-tuning this pre-trained model such that it's going to work very well for this like application. And then you have application. A lot of companies in the past 3 years have come tackling from pre-training. They basically flex their muscles like, yeah, I'm from Google, I'm from, whatever, I can train big model. And then pretty much, if you look at all the names right now that raise like a lot of money, they'll pretty much didn't produce too much value. What I kind of see more better thing is really coming from the application kind of value side. So really kind of start from application like smart news, etc. That's kind of really creating value that you are sure that people is going to pay for your value. And then your focus is to provide the best application possible using whatever technology that you have. So you can use Gemini if Gemini is best. You can use other model if that's the best. You can use cheaper model if that's going to be cost effective. But use whatever you have at your disposal to make the UX application as good as possible. And then you collect the application usage data, which is pretty much kind of what I call like post-training kind of data. That's basically kind of human and AI interacting. You create the best of those data. Because as I kind of said, AI is really good at doing the 0 to 80%. What the AI is really bad and where there's not much enough data is really the top 5% of the usage for whatever application. So if it's like, say, like a smart news kind of application, be the number one application provider for that, provide the best, smartest use case for that, and collect data. And those data is going to differentiate your startup application than other competitors. Because I think pre-training alone is going to saturate. Of course, there will be some winner and bad, but it's gonna keep saturating. Yeah.
Okay, thanks.
Richard, can I
go ahead, Corey?
Follow up on that for 1 sec too, because agreeing with that, there's one other dimension. If I were in a business and somehow had managed to not hear about AI until this session and was pondering where to move forward, one other dimension that is really important is, frankly, what business are you in? And I call that out because if you are a creative, be thinking very carefully about where your data is going. One of the aspects of building large language models, and Shane explained it really, really well, where you have multiple training steps. And if you are training a model and you're training it with your data, particularly if it is a model that is not only your model, what happens to your data in that situation? It's very, very complicated. Your content can, and if it becomes part of the training data, can be exfiltrated. It is hard for you to get out of that business deal because now your content is part of that model. And of course, you're training the AI how to imitate you. So if you're in a creative space, be thinking about using the models, which you can do without training. You can do it without information leakage, which is great. Google offers this, OpenAI offers this, but be really aware of that. And of course, with user data, please, please, please be aware of this because it is very, very easy for you to be mixing and entangling user data in ways that will bite you if you're not paying attention to these issues.
Great comments. So I want to kind of pull back on a panel comment from Jonathan Frankel in the session that was in this room at 10:30, where he said that there are some AI companies that really have no visible way of making a profit. And he said that there are other AI companies that have put themselves into a corner because they've raised lots of money at very high evaluation, and so it's going to be very hard for them to have long-term success. I'd like to ask both of you to comment on that, and how do you avoid those two problems?
Well, this is not the first time that VCs got hot and heavy about something and started just shoveling money at certain startups. If you are a startup and you are on the receiving end of that, just be thinking about what the implications are, right? Many of us in this room have built companies. Many of us have been lucky enough to build high growth companies. High growth companies have to keep growing. And at some point, the music stops and there isn't a chair for you if you aren't actually making money. So nobody should be starting a business just because they think they can go raise more VC money down the road and then get a big exit. That is a dumb reason to start a business. Obviously, no one in this room would ever do that. Tell your friends not to do it either. But I think that there is a dynamic right now where, and you are a complete domain expert on this, so you can talk about this more than I can. But if you draw the performance curve of LLMs, we haven't yet hit a slowing of capabilities, which means we don't know what large language models are going to do a year from now, 2 years from now. But there is no evidence that they won't be much, much better than what we're seeing today. And if we think about exponential curves, as exciting as AI is, we are on the baby flat spot of the curve right now. We are not on the vertical part of the curve, which is, of course, why so much time, attention, energy, and money is being brought to this.
Yeah, Shane?
Yeah, so I'm not going to mention specific names, but if you kind of Google, say, like AI startups with pretty big names kind of behind it that raise, like, say, more than a few hundred million, they haven't done pretty well in the past kind of like 3 years. And then I think the most important thing for VC kind of investor or kind of people looking to gonna go to the space is really have the highest resolution possible, better than anyone else. Resolution, what I mean is, do you know exactly where the funding teams come from? Do you know exactly like what the technology competition of that product is? So for example, text to video model. Say February 15th, say OpenAI kind of showed a Sora demo, which was never kind of released still to the state as a product, but it sort of amazed people. But basically on that day, I basically call like text to video, I don't think they have any leverage. And the reason is text to video model, the model size still pretty in the small region. And the video is where you don't have any humans as a bottleneck. What I mean is that for video, you can just take camera, take stuff, or take a game engine, you can create a high-level data. You can have the generated sample show to any person. Within few seconds, they can tell if the video quality is good or bad. So both the evaluation data don't have any kind of human bottleneck. So if you're like a decent amount of like smart engineers with like flooding of compute, you can kind of easily catch up. That's kind of sort of a kind of video space. And because, basically that was like a showing like February, and then like in April, basically there was like a Chinese startup that basically produced a really good video. In May, the DeepMind released the video that was also very comparable. In June, basically the Luma AI, and I think now there's at least like a few 5 or 6 or 5 or 10 kind of competitors on that kind of space. So you had to have very precisely what technologies. But for example, video is easy. Text is the opposite of that. For text to produce very high quality data, yeah, as he probably knows really well, but like in this kind of like information space. But essentially, like even if you spend tens of minutes of hours or days, you sometimes cannot differentiate like high quality text. So it's very hard to evaluate. It's also hard to create it as well. That's why kind of text is very different in terms of kind of pace and kind of bottleneck as a video. Similarly, for the kind of people, you need to know exactly where they come from. I mean, coming from Google is a very low bar. Coming from like there's so many like engineers or kind of researchers at Google, you need to know where exactly their background is from. So I guess like kind of one kind of...
This is because of their kind of approach to doing AI?
Because they're very different kind of researchers and engineers. Right. And then the who creates culture. The who create most value really shift. So for example, the top tier researcher that was the most sought out 4 years ago, or 3 or 4 years ago, could be useless or could be valueless in today's market. That's kind of how fast a Gen AI, this kind of technology changes. So you need to know exactly where the founding team come from, and then can they kind of compete? Do they have a network of people in the top tier competitor? So, after they release the model, and then somebody released the model, can they catch up within a few months? So basically, make sure you have the high resolution before you invest big on the Gen AI space. Okay.
So, Corey, go ahead.
And one other thing, we've kind of smushed together AI companies into one big blob. There is a huge distinction between you want to go build a competitive large language or other Gen AI model, which is the very expensive category at this point. We are talking about a tremendous amount of compute. We're talking a tremendous amount of data ingestion, et cetera, et cetera, et cetera. there's a whole nother category here, which is how does AI change what your business is going to do? Or as a startup, do you see a place that AI is going to change your business or change a market or change a sector? What is so nice about all of that VC money flowing in and all of that Google ad revenue flowing and all of the VC money flowing into OpenAI and Microsoft throwing money into it, et cetera, et cetera, et cetera, is that if you want to use a model, every week a better model is available to you and it's cheaper. Yeah. And so if you are a consumer of AI models, this is a glorious time. Now, as someone starting a business, you still need to make estimates about what those curves are going to look like, what the capabilities are, et cetera. But the general trend of every AI model available to you is better and cheaper, literally on the order of weeks. If you used to build a business because you trusted Moore's law, this is so much more exciting because every couple of weeks, better, cheaper.
So it is, but
can I add?
Yeah, go ahead, Jane.
Yeah, I really like this point, and sorry for not mentioning that, but when I kind of laid out pre-training, post-training UX, it's basically kind of hinting at two types of companies. One's a company built on pre-training foundation model. The other company is going to build an application. The one building application is way more risk, for example, there's kind of a search chatbot, you can literally hack it in a day, using an API, and literally somebody hacking a day and made a startup. That guy was a VP of or a chief researcher at somewhere there. But essentially but that's kind of where I think, and the nice thing is that we can really just kind of pick the cheapest and best model anytime. You can use an in-house model, you kind of flex some training muscles, but if it's not necessary, you can just use other companies' model. But in the end, if you can create the best application in there, people are going to pay for that because people are going to pay for that difference between 85% product versus 87% product. So that's kind of where the value is. And then if you can collect the post-training at the 87% resolution, then any other competitor collecting at 85% resolution, you're ahead of the game. And that's going to give you a company leverage.
Okay. So remember, if you're building an application, it's selling the application is how you create value, right? So people are, using your application to do something, which means that the AI is actually a cost. Right? So if you're thinking, for instance, of using an LLM that's from Google or OpenAI or whoever, and, doing a certain amount of customization to that, and, having to have, what kind of costs do you think people should look at for a good application that would use AI? How is there a percentage of revenue that you would recommend people hold to, or?
That's a really good and interesting question framed that way, and because of that, I'm going to not answer it. So, all of you doing startups, all of your friends doing startups, are all paying for compute in some way, shape, or form, right? And you're either going to some really small vendor, or you're going to AWS, or you're going to Azure, or you're going to Google Cloud, and you are baking in those costs into your margin. So there's one path where, and Google does this in a very integrated way, other vendors are a little less integrated, where this is just another compute cost. And if it was 5 years ago, you would be paying, if you're in the tech space, you would have been paying compute to do natural language processing. You're probably doing, if you're doing any sort of personalization, you are doing classical ranking. My AI team yells at me when I call it classical ranking, because of course it's a continuum, but it's classical ranking. And all that's changed is you've picked up this amazing, previously sci-fi capability that is roughly an order of magnitude more expensive, right? So can you accommodate a compute cost that's an order of magnitude more expensive to do something magical for your users? And can you do it a small enough number of times? Can you manage that? Or can you bet that in a year, one of the micro models is so good that it's not an order of magnitude more expensive than NLP, it's only 2x. Or for that matter, did you then use your LLM to build a better classifier and you're actually doing classical classification, but you used an LLM to generate a better one, right? So it's a really continuous surface, Richard, which is why it's a really complex question to answer.
Yeah.
What I would say is the moment you let employees start spending money on LLMs, like you turn on, business accounts that give them access to play with, Gemini or any of the GPTs, you will see that cost, because the ability for engineers to dork around with AI and spend money is spectacular. So be tracking it and just make sure that you aren't surprised by it, because having experienced that, it's sometimes kind of amusing.
So Shane, for you, I've got a follow-on one.
No, I can answer your question.
Okay. Okay, you do that first, and I've got a follow-on.
Sounds good, yeah. So essentially, like, I want to kind of put a proposal, which is like, we really shouldn't try not to turn the loss at all. Essentially, like, create the AI application product that you can charge from day one for the value that's bringing. And then optimize the UX, the design, the capability. And you can do a lot of stuff. You can mix in different models, you can do that, but make sure that whatever you want to charge for the application and that costs sort of kind of really kind of makes sense from day one. And the reason is that, like, technology is changing very quickly. If you're going to invest any amount of data, any amount of money on pre-training and post-training, then that model may be, say, like valuable for like a few weeks or kind of few months, and then you got to do it again. So essentially, like, it's going to be pretty big sunk cost. Essentially, the kind of competition, the kind of model training is really brutal. The top talent's going to working insane number of hours and then getting paid super high. And then essentially, like, there also like only a few companies with that kind of crazy sort of like that will kind of push it. So my recommendation is really like, try to kind of create the value first. They'll justify whatever cost.
Yeah, that makes good sense. Shane, how do you answer people who ask about vendor lock-in? Sorry? Being locked into one vendor.
Oh, the worst vendor lock-in.
If the models are getting better that much faster, should I wait?
Do you know the worst vendor lock-in happens? Is the vendor. Like Google, for example, we have applications, but we have to use.
Right, you're going to use your application. Yeah. Right, sure.
I mean, like, same say like Meta, right? So Meta, for example, is like has, like a very big SNS application. They can sort of like use the best LLM to reinvent the SNS, but they're locked into Llama because they invested so much money. They cannot say, oh, sorry, Llama is not really working well, so we use OpenAI or Google. They cannot say that. So essentially, the worst kind of vendor lock-in actually happens on the vendor itself, and everyone else should just like watch it and enjoy it.
Yeah.
Yeah.
So Corey, on that one, and a further question for you is about model drift. How do you start to recognize model drift? But go ahead on the first one.
So vendor lock-in, if you are an application developer, is non-existent. Just let's be super clear about this. There are 10 competing ways to abstract it, or you need one engineer in an afternoon to abstract it. Like this is the easiest engineering work your team will ever do. Yeah. Like this is not me making this up. That's the easy part. And because everybody's trying to steal business from each other, the semantics of the models are all very, very similar. There are some tiny changes, but it's actually one of the most consistent technologies. Like compared to moving between cloud vendors, which is actually genuinely hard, switching models it just isn't an issue. Like it may be an issue because you're on Google Cloud and you want to keep using a suite of Google products. Like, so you might have some slight bias, but from a technology standpoint, it's non-existent. In terms of model drift, which is a really good question because the models keep changing, they keep getting updated, their answers keep changing.
And the outside world keeps changing.
Allegedly. And also all the vendors are constantly optimizing their costs behind the scenes also. It basically is making your quality problem harder. Like and this, by the way, if you have teams that haven't worked with large language models before, engineering teams, non-engineers will not have any problem with this, but engineers will be driven mad because the results aren't deterministic. And so you will find use cases that actually would be perfect with LLMs, where you will have engineers on your teams come back to you and say, well, no, this could never work. And when you dig in far enough, what you find, it's because they are a very, very highly talented engineer who spent their life getting really good at deterministic results. And that isn't what LLMs do. And so it's one of the many sort of surprising gotchas here in that actually sometimes PMs, folks with some engineering background, are actually much more adventurous connecting products to AI and discover things that work and then get really excited about it. So, but the model drift is really no different than you have to build systems that are resilient to non-deterministic results, including, by the way, models that say, absolutely, we promise we're going to return in this format. JSON is a format. They promise they're going to return in JSON. And some percentage of the time, they're like, no, just kidding. I'm going to return in a different format. So you just have to build for that. And once you've built for that, accommodating model drift is no more complicated than anything else. And going back to the initial quality discussion, you, of course, will be evaluating multiple models all the time anyway.
Go ahead.
Yeah. One of the most important thing I think for the application company is to really have high quality post-training evaluation. The hardest part of really building our application is to kind of how to evaluate it. And a lot of like a classical sort of like even machine learning engineering tuition don't really come here, because until the elements really kind of came into place, it was really about like task specialization. You fine-tune a task, you define the metric very clearly, create a lot of samples to reduce the uncertainty, and then you have like very narrow task measuring metric, and then you just optimize hill climb against it. But the post-training or kind of how the cases where LM can fail, they're very drastic, and then you cannot really kind of use classics like heuristics to catch them all, and then so where to use humans, where to kind of use some automation, where to even use like LM. But getting good at post-training evaluation is actually one of the hardest part. In fact, like I know like some kind of people who say drove that OpenAI's O1 stuff came from just evaluation, kind of like work.
Well, and another piece here, and only because you mentioned post-training. So smart news, we don't do any training and we don't do any fine-tuning. And our reasons for that are we feel that partner content should never go into models. We just think that that is a mistake. We think it is misaligned incentives. And so we make very strong statements about that. It also means we're constantly just testing against vanilla versions of the models as well. And so it is something else to think about, particularly as prompts get much larger, context windows get larger. There's going to be another shift between what is the most cost-effective and efficient way to use these models, or sometimes what is the best way when working with your partners to think about using these models.
So a couple of more questions from me, and then we'll open it up to the audience. The first thing that I need to ask both of you is, what do you see as the current state of affairs with regard to regulatory risk? Whether it's about, privacy, or whether it's about, how long we'll be able to scrape the internet, how do you see the situation? Should people be concerned about that now or not?
Yeah, I don't think I can comment on that.
Okay. How about you, Corey?
You're not going to answer how long you can scrape the internet? I was going to look forward to that one. So look, we are operating in a lot of changing regulatory questions. There is no doubt that a lot of copyright content has ended up in these models, and that copyright was not intended to handle this use case. And I'm speaking of for US, I'm not a lawyer, but from the US perspective, it's quite clear that there are going to be on the order of a bazillion legal cases about this, and it's going to take some amount of time to resolve. At the same time, every company working on models is getting better at synthetic training, synthetic data, unsuper, blah, 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 right? Like the arms race to get really good at doing this with either content that's been paid for or with content that you actually have full rights to is also ongoing, because everybody recognizes this is a problem. I already got on my soapbox about user data. Just be careful. If you are starting to use LLMs, or people at your company are starting to use LLMs, or you've turned on like ChatGPT, right? Make sure you check where the checkbox is on can OpenAI train on your data? Because guess which way it defaults, although they keep switching the default, which also means you have to go look at it, right? Because these are ways that you might be accidentally leaking data. And if it's personal data and, oh, I don't know, you're dealing with medical data, for example, you really don't want to do that because that's bad for everyone. So there are risk vectors you might not expect, even if you have a really good compliance team and a really good security team. So this is a case where you do have to do your homework and you do have to learn.
Let me add something. So we definitely try our best. So for example, for the a lot of kind of data, there's a very strict a PI kind of filtering, and not just based on algorithm, but also really through manual human inspection, because algorithm can fail. So that's that. And then, for example, if there's some training run with more sensitive data, then you often train a model with it and without it. And then even if the performance degrades, if the basically legal team determines not, you definitely kind of follow the kind of law. So there's definitely kind of best effort. Also, in terms of a technology and research, for example, there's a research a Sync ID that basically says anything with an image generated, video, and then the speech that the Google GenAI can provides has a Sync ID, which are basically invisible, undetectable, sort of markers, basically watermarking. That basically says okay, this is generated from Google, and then a small amount of say modification can't really remove the watermark. So I think those kind of technology, and then just making sure the big companies, and then also the Google's a big company, but also the GenAI companies are now valued very high, so they should also kind of be responsible and kind of follow it. Make sure that all of those kind of company follow, I think, are pretty important.
Okay, so my last question, as for non-engineers, okay, individuals who are using some sort of a GPT or whatever. So generative AI is a massive new kind of tool, and we need to learn how to use this new tool. In the days of slide rules, you made some kinds of mistakes, and when you switch to calculators, you make different kind of mistakes. So what do people really need to learn that are new skills about how to be successful in using AI?
Yeah, I think one kind of most general principle is that treat it as a human. It's a very different than that, but then it's something is a technology that's so general and then approximate the kind of human intelligence probably the most. So you can still kind of treat it. So for example, I'm not very good at memorizing birthdays of famous people, so don't expect the OLM to be good at it. If I do 10 digit kind of arithmetic, I'm not really trained for that. So in a way, that kind of provides a bit of, because even though the algorithm and the biology mechanism hardware is very different, the principle of learning, this network prediction, is pretty much the same. So essentially, that basically shows there are a lot of intuition transfer. One kind of example I can give is that essentially in 2022, I basically figured out that all those kind of technology can really kind of scale to the entirety of the human intelligence and the capabilities. And one of the kind of work that showed is actually, I'm part of a co-author of the paper, but it was a student in Japan that basically before then, for example, for arithmetic, you just kind of ask for the answer. But then what if, just ask it to take time to think step by step. So really kind of treating the LLM as a human and just ask it, just kind of prompt it. And then because it's trained on human text and human thought processes, it's going to imitate that. So essentially, kind of one of the things.
There's an awful lot of ambiguity in natural human communication.
For sure, but that ambiguity is kind of what makes the world beautiful and interesting, and the world is full of surprises. So of course, there's a true or false in that, but in a way, I kind of this kind of a noise in the human data and also AI data is kind of what makes the world very interesting. But yeah, that's
okay, Corey.
So I agree with all of that. I think about AI as the first partnered product that we've ever been able to create, right? You are partnered with it when you are working with it. A good rule of thumb is think about whether it's better than the best available human you have access to, because in a lot of cases it will be. But think of it as a partner, not somebody just telling you what to do. The failure modes with AI, with LLMs in particular, tend to be when you just are throw a bunch of stuff at me and then you just believe it uncritically. I would encourage you, Boston Consulting Group wrote a great research paper on this. They went and took their teams, they partnered with an AI, they went and did work, but they categorized it into results when the AI knew what it was talking about and results when the AI had no ability to be helpful. In both cases, the teams were faster. In both cases, the teams were more believed by the people who received the work. But as you might guess, when the AI didn't know what the hell it was talking about, the quality of the work was a disaster, right? But it was more credible and done more quickly, right? So that's when we start talking about how do we start thinking about this as we go forward. It is learning to operate with partners in our work environments who might not know enough to help us.
How important is it to know how the models actually generate results? Because even though the interface is very human, it's arriving at the conclusion in a way that is not matching the way the human brain works.
So I'm going to leave the detailed answer on that to the expert. But I will ruin your answer by being, to my knowledge, nobody knows how they're generating the results. So, though then again, we don't actually know how we generate results either. So at least they're maybe equally unknown. But I do think it does. So the less glib answer is, it is certainly useful to know the scale and scope of the product you're using, like the difference between an on-device model that's sort of has 30% accurate on things versus the completely state-of-the-art models that are sitting here at 80, 90% of most results. That's useful to know. It's a little bit like, you know your coworkers. Do you really want to ask that particular coworker for help versus the one you really wanted to get help with?
Excellent. Shane, do you want to finish up on that?
Yeah, it's definitely kind of hard question. I think one thing to know is really just like the basic algorithm. Like you don't need to know about transformer. You don't need to know about all those kind of details about that, but just kind of know that the LM learns by predicting the next word. And then basically like one kind of intuition that I really kind of learned from Ilya Sutskever, who's like co-founder of OpenAI. He was a longtime Google Brain researcher, and then Jeff Hinton, like Nobel Prize winners, basically one of the, pretty much the best disciple. He basically can explain very clearly that basically to predict really well, you need to understand the data, the causal mechanism of the data. In like some technical terms, like Solomon induction is a bit related to that. But essentially, like the best predictor is if you find out the causality of the data. So for example, if you want to predict the next word in the Amazon's review, then you kind of need to, if you know about, say, the sentiment of the person based on the writer, which is a kind of causal sort of kind of graph, then that allows you to predict the future token better than other.
And that's kind of a domain knowledge.
Yeah, and then so that's kind of one, I think, just to kind of know about online algorithm. And the other thing is to have like a rough understanding on how much data there's the internet that people kind of already ingesting at what compute cost. So text data, video, so text, that's kind of first thing. Programming, there's a lot of high quality programming data. And also program is much more low entropy, that like, many tokens are much more predictable than natural text. So understand about this kind of differences, and also just like how many dimensions, for example, for images, like how many tokens that translate into like a text. Have some rough idea on that, but best way to find out, just play with the model, the best model.
Yeah, well, and relevant to this audience, most of the training data is still English, right?
I don't know how much I can say, but essentially there are a lot of data. And in fact, there's a lot of Japanese data, because Japan basically modernized the earliest in Asia, which is huge because Asia produced so many high quality tokens. So actually Japanese text is actually very large, maybe next to English. But, but those could be down-weighted, in the training based on the priority of the market or just like who's on the training team.
Okay. It's a good time now to open the floor to questions. So, Hori-san, you get the first question. We'll take about 3 questions each.
I'm Yoshi Hori of GLOBIS. I have a question about education. In the era of AI, what kind of skills will be needed in the future, and how the education will be changed? Would you allow your students to use Gemini for exams or reports? That's the question.
Great, thanks. Another question. In the middle. I saw 2 hands in the middle, and I saw a hand over here.
Kazoyano, just a technical question. There are a lot of interest in AI agent and agentic use of AI and LLMs. And what's the impact of that AI agent in value or impact of the AI?
Okay, great. And one more question. Right by you.
Hi, good afternoon. I'm Angelo, MBA candidate. Corey raised a good point with regards to copyright. So I'm curious about Google or ChatGPT. Have any of the other companies contacted you regarding restrictions on the use of their intellectual property on your applications? Do you get the question?
Okay. So let's take that last one first. Okay. Corey, for you, are people putting restrictions on your use of the material that you're accessing?
So every publisher out there to first order is involved with a lawsuit with at least one AI company right now. Smart News, from its very beginning in Japan, did something really unusual for a technology company. It paid for content. And so we have all the content we serve, we're in contract on. So we pay for it, we give credit, we give compensation. So we are quite an outlier on this, and we think that's really important. But broadly, if you look at the legal space, you see a lot of creators asserting restrictions on their content. And this is in multiple domains, whether written, video, et cetera.
Okay, so let's work backward. Shane, AI agents. What can you give the 30-second explanation of what an AI agent is for everybody in the room? This is one of the things that people are saying is the next big boom in generative AI.
So essentially, since the ChatGPT launch, people mostly have been kind of using the basically AI as Q&A, so pretty much like an FAQ. But basically, AI agent is that it can do many steps autonomously of that. So it can basically say, given the problem, you can break down the problem into, say, steps it can take to solve that problem. And within each step, you can also kind of break it further down and have this kind of continuous autonomous loop. And I think another critical thing about the AI agent is that it has access to additional help. So for example, the help has access to Google search. You can write the program in Python and execute it. And then it can also call another agent to verify its kind of answer kind of stuff. But essentially all those things kind of combined can make the capability of the AI model from 10% to 90% depending on different kind of applications. And you're going to use more compute, but as we mentioned, compute is going to getting cheaper every kind of few weeks. So AI agent is a very promising kind of direction, and it's actually kind of a big direction that post-training is kind of very focused on. It's basically a new kind of UX where you have a new kind of data that's different from ChatGPT.
Okay, great. So there are two aspects to the education problem. One is what are the skills that people who are going to be engineers need to be taught? And the other is how AI is going to influence what I would call the education business. Let's take a quick view at both of them. First of all, what's going to happen to engineer training? Okay, so how will it change what students learn? Okay, what students learn in school. I'm sorry, you're right.
Yeah, so programming, mathematics, those are the easiest because their data is the cleanest, in a way. And then it's also very objective and also can be verified automatically by machine. It doesn't need to even require OM to verify. So those can change very quickly. I think when let me kind of step back, and then when I consider AI and education, I kind of think in terms of two directions, two competing forces. One force is basically how can we overcome the biological limitations? We're not LLMs. So we're basically trained through evolution. So essentially, we need certain sort of curriculum learning to be smart, to be able to differentiate what's fact versus not, to be able to differentiate if the person's lying to us or what's the intention. We need a lot of training for that. And then to train for this kind of logical thinking, intuition, actually say math and programming are very important because math and programming, one of the kind of only principles where it's either 0 or 1. Many of kind of logical thinking is very kind of fuzzy. So if you kind of cascaded, you cannot. But math and programming, you can have like 100 steps in sequence. It can tell if it's like true or false. So it's actually very good ground to do curriculum learning for logical reasoning. On the other side is really the business, like what's really needed by market. We cannot deny that from now on, every kind of job, we can use the Gen AI, we can use the LLM as a helper, just like kind of 10 years ago, we can use Google search as kind of helper for that. So that's not going to change it. So that can sort of like automate, say, things, even like, say, simple programming or like math out of it. But those are kind of competing to each other. And then that's kind of where I find education to be very difficult to decide, like, what's the good education curriculum.
Corey.
So I'm going to disagree maybe a little bit on this one. So I've been paid to write code for nearly 40 years at this point, and I feel very fortunate that this particular period in human history, that was a valuable way to have a career. And at least in the United States, the last 15 years has been STEM education saying we need to teach everybody how to write code. That is the one true path. I think it is incredibly unlikely that that is the correct path going forward. Because many of the things up until now that you had to learn how to write code to do are about to have AI partners who can do that, the grody coding part for you. I don't disagree that coding, like mathematics and other disciplines, are useful for teaching rigor and intellectual honesty and these other pieces like that. That seems very important. But because AIs tend to collaborate with you, it's actually going to put more pressure on how good are you at collaborating? Like, how good are you at working with each other, with tools? How good are you at learning? How good are you at adapting to change? And the flip side of that for education is, frankly, how are we going to overcome what are largely regulatory related challenges to, again, go back to my comment about best available human. I could today build a tutor in a brief conversation and prompt with any of the large language models that is substantially better than a student having no tutor. It's not better than a human, but it's way better than nothing. And what those efforts, because we're watching startups try to move into that space, what you see is they run into well, you're not as good as a human. And that's not the right bar. The right bar is for all the people who don't have access to a private tutor, who don't have access to a specialized tutor in a field, who don't have access to a partner for language learning, right? We all know that language learning is better when you're in conversations, when you're immersed. Have you seen and used some of the AI models that are doing that today? They are mind-blowing. And so the technology is actually getting better at education much faster than education is ready for it, which is not unusual for education, right? Education is a very conservative field, but we are already able to do things that are transformative to for our most vulnerable learners, the ones who don't have access to a tutor, who don't have access to things.
Thanks. Those are both great comments. I think we've got some questions from online.
We have 2 online questions. The first one is, in terms of business development and monetization of AI applications, which industry do you think will be the quickest to succeed in monetization and scale, and which industry do you think will be the slowest or most difficult?
Okay, that's one. Second one?
Second question is, what will it take in AI development for AI to go beyond 0 to 80% to become good at solving the most difficult 5% of a problem?
Okay, great. And let's take one more question.
Tatsuya Teruzawa from IAJ. I lead an energy think tank. One of the big discussions is that with the widespread use of AI, there will be massive demand for power. So it will make the challenge to realize carbon neutrality even more difficult. So my question is, can AI make our energy consumption more efficient? And if so, how? And what's the magnitude? Can it totally offset the possible increase in energy consumption?
Great. Let's go from the first one. In terms of business development, industries that you see moving fast, industries that you see moving slow. Corey, why don't you take that one first?
Yeah, it's a good one. So we're starting to see anywhere we're having AI interaction, where AI can replace a human interaction, we're seeing move very quickly. We see this in everything from like customer support cases to onboarding cases. We're starting to see AI make its way into video games. That's going to move very, very quickly. Obviously, as much as text is some of the hardest processing cases, it's also expensive processing. So you see AI being used in a lot of data analytics and legal and everywhere where there are huge corpuses of text. And so all of those cases, we see it moving really fast. And most of those business areas, particularly things like legal, they're used to paying for software as a service already for a bunch of stuff. And so you see companies just plugging in.
Very briefly from me, in terms of activities, you see a big difference between how bad the consequences of a bad AI output would be. So you see an awful lot of marketing materials being written by Gen AI, but you don't see many diagnoses in medicine. Right? Because the consequences of some sort of a problem would be much more difficult to deal with. Go ahead. You're seeing tools for the doctors to get to the diagnosis.
Well, and also let's not be too hung up on chat style interfaces. Actually, machine processing of radiological is now better than human.
Okay.
Right. And so we see that being applied all over the place.
Okay. Shane, what's it going to take for an AI to get up to the top 5% to get the hardest problems?
Yeah, it's basically kind of hill climbing process. So you had to to get to top 5%, you first had to go from 80%, which you can code up in like a day. You can just connect your application to the API, and then there you have 80%. That's the starting point. And from that, you're basically going to collect a lot of, say, usage data. And there you can basically find the different sort of a corner failure cases of the model. And once you have those a failure case, you make evaluation, and you start doing maybe some post-training or even some prompt engineering to optimize the metric. Then you get to maybe 82%, etc. And then using the 82% product, you can collect the data that can maybe in that higher regime. So this is incremental process. And then I think this is why you cannot have any time delay in, say, waiting for the pre-trained model. You cannot, say, wait even half a year for your pre-trained model to have a chance of getting better. You don't have time because in that 6 months, people use the best LLM, have better application, there'll be continuous hill climbing. So this is why I think the application driven stuff is going to be more valuable. At least for a while.
Great. Go ahead.
And of course, the other place. So I got my start in video games where all you're doing is cheating all the time because you're trying to solve problems in ways that people don't expect and taking advantage of you don't have as much compute as you wish. Look, if you're looking at an AI problem and you're blocked as a business till you get to 95%, rethink the problem, right? Because you have magical powers now, so you're probably not thinking about the problem the right way. It's like the programmers who are I don't know how to think about non-deterministic solutions. Be thinking about your problem differently so that the 80% case, but it's an 80% case that was not available to anyone on the planet 6 months ago. Right? Figure out how to make that valuable.
So in the last minute that we have, the sustainability problem, massive electric power consumption by the LLMs and so forth. Corey, do you want to take it first?
Oh, sure. The non-Google person's going to answer this one. No, so this is a challenging problem. Conveniently, crypto has cratered and freed up a bunch of compute. So that's worked out well for NVIDIA and others. And joking aside, this is real. AI is actually not as inefficient as crypto. So comparatively, that's good. It's also, much more useful. But, you've watched some of the big companies slightly restate their green goals because this is so challenging. But what's going to happen? The models are going to get better. More of the models will start going toward on-device and really small models. It's part of why things like the really small Gemini model is so important because that model does so much with so little. It's built to run on Android phones. And if you've ever tried to do any compute on an Android phone, you know how impossible that is. And so the reality is things that right now are only running in data centers, we're seeing those models be used to train smaller, more power efficient models. So that will help. Also, you'll see as agents come along, more ability to time shift work, because guess what? Somewhere on the planet, there's solar power available. And if you don't need the answer right away, you can decide to not pay for it now and instead let that workload shift. And this is something that companies like Google are extremely good at and are very incented to become more power efficient.
I think he already answered all the good efforts that Google is already doing.
You can't say.
Yeah, but essentially, like in terms of the compute side, have a really best model. You can train a smaller, like very good model that can be kind of competitive in kind of many kind of cases. So this is kind of why it's what's driving the Gemini cost to go down very quickly, especially kind of recently once we kind of have a good model. Another thing, he already talked about asynchronous stuff. Some company already kind of released kind of asynchronous batching, so you can just like send a batch request, and then you can just like you have a time window, they will get the response back. But that can really kind of make it this kind of like thing work well. But also like I think in terms of kind of energy and things, that's also should be kind of part of where we iterated UX. So he kind of mentioned a very good point that you should really reconsider UX if your pre-trained model is not giving you, because it's a really magical model. I think similarly for the energy as well, we can kind of think about what are other conventional ways we're kind of wasting energy, and then where we can use LLM that can actually make sense even in an energy way. Like don't just kind of think in terms of inference costs, but also kind of take account of how other kind of energy components work. And I think pretty sure there will be a lot of places where the LLM can actually lead to reduction of energy a lot. Yeah.
Thanks. So earlier this year, okay, Corey, go ahead.
No, so 50% of your power budget, if you're on a mobile device, is the screen. If you can recognize a voice, you might not need the screen. So it's like, it's actually thinking about these problems differently. And I love that you started itching at that because it's really important.
Okay, great. We're out of time. Please join me in thanking our panelists.